This video is going to build on our knowledge of logs, and we're going to apply it to situations where we have to solve log equations. So if we look at worked example 7.5 part 1, then what we have at the moment is we have a number which is written in log format, and what we need to do in order to solve this is we need to write it in its power format. Now we know the base number is 10, so we will write down the number 10. We know that the word log also means power, and this log is equal to 2, therefore the power is equal to 2. We then put the equal sign as we did before, and then we write down 3x plus 1. And by taking it out of its logarithmic format, we've ended up with a linear equation which brings us back to second year mathematics. So now we solve this linear equation. 3x plus 1 is equal to 100. 3x is equal to 99, and x is equal to 33. Now, when you work out a solution for logs, it's always a bit prudent to actually go back and make sure that it works by testing it in the original question. Okay, we're going to look at part 2 now, and unfortunately part 2 is a trick question. And it says log to the base 2 of x plus 3 is equal to log to the base 2 of x minus 9 to be squared. And the question says find x. Now the issue here is that on the left hand side we've got one item, and on the right hand side we've got one item, and both items start off with log to base 2. Now, as a consequence of that, that means if both sides are equal and both start off with log to the base 2 at the front, then the insides of the logs must be actually equal to each other. So therefore, we can go straight to this line that x plus 3 is equal to x minus 9 all squared. And now what we're going to do is, again, that's taken us to a low level of mathematics. We're going to have to expand this, work it out, and solve whatever the equation is. So we've got x plus 3 is equal to x squared minus 9x plus 81. Bring everything over. Minus x squared plus 9x plus 9x plus x plus 3 minus 81 is equal to 0. So we recognize it's a quadratic equation, so we brought everything to the left hand side. X squared plus 19x minus 78 is equal to 0. And now we're going to change all the signs. X squared minus 19x plus 78 is equal to 0. And what we now need to do is to solve this quadratic equation. We can do it by using the factor pair method and quickly running through all the possible factor pairs of 78, which you can do on the calculator very, very, very quickly. So let's do that now. So we've got 1 and 78. We've got 2 and 39. We've got 3 and 26. And looking at 6 and 13. Now 6 and 13 add up to give you plus 19. So therefore the pair we're looking for must be minus 6 minus 13, which will add up to give you minus 19. So x squared minus 6x minus 13x plus 78 is equal to 0. Factorising in pairs, got x minus 6, put x minus 6 over here, equals 0. Minus 13 is the factorisation. So you've got x minus 6 on x minus 13 is equal to 0. And the two solutions are going to be x equals 6 and x is equal to 13. Now what we've also got to do is we've got to check that both these numbers work in the original equation. So we just put it into the calculator and make sure they both work, and then we write down satisfies the original equation. You must be seen to check them. Okay, so now we're going to go on to this example here, and for the first time what we have is a situation where we're going to be using what's called the laws of logs. And the laws of logs are in the formulas and tables book, and I'm just going to pull out an extract for us here. And what we have is we are required to solve this logarithmic equation, and we can only solve logarithmic equations when we have a log on one side and a number on the other. And unfortunately what we have here is we've got two logs on one side and a number on the other. So what we need to do in order to solve this is use the laws of logs. So what we have is a subtraction of two logs. So this is this formula here, the subtraction of two logs, and what it does is it becomes the division. So the x is going to go on top and we're going to be dividing by the y on the bottom. So the left-hand side becomes a single log, and the first number, which is x plus 1, stays on top, and the minus part becomes a divide by x minus 1, and that is equal to 1. So we've got a single log on one side and a number on the other, so we can turn it into its power format. Now we know the base number is 2. We know the power is equal to 1, and this is now going to be equal to x plus 1 over x minus 1. We're going to multiply across by the bottom, which is x minus 1. And when we multiply across, we're going to get 2 on x minus 1 is equal to x minus 1 on x plus 1 all over x minus 1. And then it's going to cancel, and we're going to end up with 2x minus 2 is equal to x plus 1. It's a basic linear equation, so bring the x over to the left, bring the numbers over to the right, and we end up with x is equal to 3. Don't forget, you must always check that the solution satisfies the original equation, which it certainly seems to do because it says up here x has to be greater than 1, and indeed x is equal to 3.